I'm going to speak about these items, some general notes on expressing color in PDF to begin with, how to get appearance of spot color right in PDF files, how to print PDFs with spot colors, how to display as opposed to put them on a substrate, like put them out on a screen or video projector, how to display spot colors, what does CXF bring to the table, and what to aim for. So what is the conclusion of all the various aspects combined. You can express color in a number of ways. I'm going to speak relatively fast because I have to finish at 45 minutes past the full hour. Expressing color in PDF can be done in a number of ways. Three areas. One is process color. The process color is RGB or CMYK or grayscale or LAB. Gray, RGB, and LAB are additive, and CMYK is subtractive. And you can already express CMYK not just in a device CMYK or a C-based CMYK color space. You could also use separation color spaces that have names such as cyan, magenta, yellow, and black, and address the components of a CMYK color space individually. So that's process colors. That's the easy part. Okay. You can also have spot colors. Spot colors are as much as CMYK subtractive colors. They are expressed using separation color spaces. You just have a channel of a certain spot color. One we call them color, and we call the spot color and colorant, and so on. Some of these spot colors are used for non-color purposes and actually for non-printing purposes. People tend to use them for varnishes and dye lines and all kinds of things. We have to keep that in mind when speaking of spot colors in PDF. So strictly speaking, these are not spot colors. They are a technical use of a separation color space. And then you can mix color in a number of ways, including mixing process colors and spot colors. And a very simple mechanism to mix colors, at least on the output for printed output, is to use overprints. You have cyan, you have a spot color orange. You tell the orange to overprint on top of the cyan, you get some weird mixture. It's probably not looking nice in this case. You can get a similar effect by using transparency. It's not the same as overprint. It works in a completely different fashion, but it makes it possible to mix colors. So you have CMYK, some combination of CMYK, and a spot color orange or pink or whatever printed on top, and the result would be a mixture of these 5 color channels. You can also use device N, which is yet another color space in the syntax of PDF, where the color space enumerates the colorants that are going to be used for a certain object. You could have, for example, magenta, yellow, and blue. Blue is not a CMYK color, it's a spot color. If you could set up a device N color space that uses magenta, yellow, so you could combine them, gets red somehow, and maybe then a blue. And you could mix the blue and the yellow and get a green effect, and so on. So that makes it possible to combine arbitrary channels, including spot colors and cyan, magenta, yellow, and black. In any combination you want. Now let's have a look at spot colors. What color do spot colors have? Whatever ink you throw in the printing machine, that's the spot color. So in PDF, there's not a definition for each and every spot color, what it looks like. This is different from RGB or CMYK, where you do have at least some indication of what 100% magenta and 100% yellow printed together may look like. It's probably not looking green. So in order to communicate the appearance of spot color, if it's not printed on a printing device that does have the spot color as an ink on the press, you need to define its appearance somehow. And it's done in a number of ways for the various variations that you could think of. So for separation color space that kind of represents just one spot color, like maybe orange, there would be an alternate space. Alternate space must be a process color space, like CMYK, RGB, LAB, and so on. And the tint transform. The tint transform is a small formula, so to speak, that takes the input value, like 30% orange, and then does a little bit of mathematics or lookup and says, okay, 30% of orange looks like this in CMYK. Well, it's like whatever that is in using magenta and yellow in CMYK. So that's a mechanism to tell a rendering device what to output if the spot color or the ink orange is not available. This applies both to displaying on screen and also printing on a laser printer that only has CMYK laser or an inkjet that only has CMYK. The same is true for device end. Device end is an arbitrary combination of spot colors and maybe process colors CMYK. Each of the individual channels could have its alternate space, but also the combination of them can have an alternate space in a tint transform. So if I have magenta, yellow, and blue, I can define a tint transform, a formula that takes the 3 input values, 30% for magenta, 20 for yellow, and then maybe 10% for the blue. And then have either a formula or a lookup table to tell a device that's going to print it on a laser printer or put it out or output it on screen what computations to do or what lookup to do to make it look like the color that would be printed if you had the actual inks in your printing press. I will not go through every item because I have to stop at 45 minutes past 5. There's a couple of other things. There's the hack for device N, color spaces, to get interesting effects, very often used for duotone images in Photoshop and so on. There's device N channel, that's a special flavor of device N, which has yet another mechanism to go from the colors that are in device N, like my magenta, yellow, blue combination, and then go to a 6-color combination, because you may have a 6-color press with like cyan, magenta, orange, black, cyan, magenta, yellow, black, orange, and green, and it would have some lookup or mechanism to go from the 3 input values to those 6 output values, and so on. There's another interesting possibility, which has only been available in PDFX 5N and was added to PDF 2.0. That is the possibility to reference an N-channel ICC profile. An N-channel ICC profile goes beyond the CMYK profile because it can also have on top of CMYK several spot colors, one or several spot colors. So I could have cyan, magenta, yellow, black, and orange and blue, let's say. And if I have that as an output profile, I indirectly also characterize what the combination of inks as defined in the PDF and overprinting each other might look like on the output device that is characterized by such an N-channel ICC profile. Then in PDF 2.0 there are 2 more options, mixing hints, which I will not get into because it's hardly used by anybody. And then the last item is a spectral data entry, which can be filled with CXF X4 representations of spot colors as they have actually been printed on some output device. And it's an XML representation of the spectral reflectance curve. You send light at different wavelengths to the printed sample, and you measure the reflectance of that wavelengths, and then across the range of visible light, you can find out how much of blue and green and yellow and red the spot color is reflecting, and that gives you a very good handle on dealing with that spot color, also when it's interacting with other colors or with a substrate. This I more or less explained already. So for a spot color or device N color space, you can have a representation that helps you create a visual appearance if you don't have the spot color ink. And just to give you an idea what is possible doing this is, so this is a typical alternate representation or alternate color space with tint transform for spot color orange. I call it linear orange because the next slide will show a not so linear color appearance. This is 99% of spot colors we are dealing with are done like this. You have the 100% color value, and everything in between you interpolate. Yeah. So if you in InDesign or Illustrator, you define your orange, you say, okay, this much of magenta and this much of yellow in the alternate color space CMYK makes it look like orange. That's my alternate color space and tint transform definition, which is essentially just 100% is like this, and 50% is like 50% of each of the values that you find for 100%. This doesn't have to be like this. The mechanism in PDF is much more flexible. You could do this, and this could actually happen. Of course, this is somehow exaggerated, but you could have inks that don't have a linear behavior. You could have an ink that is pretty much the full tone until 80%, and then it kind of shifts the color angle to something else, and then already it fades out at 20% and doesn't really print anymore. Things like that can happen. The extreme cases are metallic colors like silver, which essentially only print correctly at 100% anyway, but there are other colors depending on the pigments used and the carrier material used for the pigments that may kind of have a switching behavior. So in this case, it's pretty green for 50% and above, and it gets bluish below 50%. In this case, PDF gives me a number of possibilities to express for each of the steps what the best representation is, in this case in CMYK. And it could be very different for 50 and let's say even 49 or 45% of the spot color. So it doesn't have to be linear. There is more to it than just a value for the 100% ink value and an interpolation for anything between 0 and 100%. Nonetheless, if you open this PDF file in Preview, for example, not in Acrobat, in Preview, it will look like this, because Preview doesn't care. Preview finds the equivalent value for 100% of that ink and will interpolate. So Preview is ignoring the alternate color space definition. So just to show the difference, and actually it's not just a Preview, it's also Adobe Reader, because Adobe Reader doesn't have, at least in some contexts, the good display of PDF files. Apple Preview, Chrome, Firefox, Safari Edge, iOS, Photoshop does it, unfortunately. It may also happen after you import the PDF to other applications like InDesign, Illustrator, QuickExpress, Word, and so on. They all show this nonlinear green like this. So there are some limitations in the field.
So what's the alternate color of this nonlinear green?
The alternate color? What do you mean by it?
So it's CMYK, LAB, or...
It actually doesn't matter whether you use CMYK or LEB or RGB. The problem is that most applications, excluding more or less Acrobat Pro and PDF Toolbox, of course, despite the fact it's being defined like this, most applications will only look at the 100% value, and if the PDF file asks for, let's say, 50% of that spot color, they will interpolate. Or 40%, they will interpolate. So they will give you this value in CMYK, let's say. They should have given you this value.
So is there a color shift in the right column or not? It looks like a color shift for me on the
It might be, but the important thing is like the big step between these two, right?
Yeah, okay.
This is fake.
Okay.
Yeah. I mean, it does happen, but I didn't want to go look for a file like that. It's fake, so I hand-made it in PostScript and sent it through distiller and then just did it. But anyway, it shows the point. And so correct rendering of the spot color at 50% would look like this, and at 45% it would look like this. If you do the rendering in any of these applications I listed, 50% will display like this, and 45% like this, which is not good. Is it clear so far? You could probably do slightly better using the ICC, internal ICC profiles I mentioned, but because they also give a good representation of all the color value combinations between CMYK and the one or several spot colors you have, including where you use just one or two of the spot colors, who are printed on top of each other. It's a pretty powerful and flexible mechanism. The big problem is Acrobat Pro supports n-channel profiles to a certain degree, but you have to manually set it up in the general preferences for Acrobat Pro, and even then it's finicky. And beyond that, only specialist tools support n-channel ICC profiles. So for the mass market, there's probably, you can say there's no support. We support it in PDF Toolbox. The big proofing systems, of course, can do this, like GMG and ColorGate and what have you. But the Creative Cloud applications don't support it. Acrobat only supports it with a lot of pain. So, with all that in the back of our head, we can look at two situations. One is printing, like production printing, when I print on the press that actually may have the spot color ink or may not have the spot color ink. If the printing press does have the spot color ink and the data has been prepared properly, it will print fine. There's not rocket science behind that. Yeah, you have orange ink in your printing press, you're asking for 50% orange ink, and you have imaged your plate in the right way, and you have set up your press properly, you will get 50% of orange ink on the output, possibly printed on top of some value of cyan or some of the other colors. That's the easy one. If you happen to be printing on a printing press that doesn't have orange, some color conversion will have to take place. So if it's a conventional 4-color offset press or also an inkjet press with just CMYK, and you have this orange spot color, somebody will have to do the conversion. I think, you know, this is daily business for many of us. It works quite well in general, but occasionally you will run into a problem because there may be some problems that cannot be easily solved, except by rendering the whole page. So if you have orange overprinting on top of, let's say, cyan, it's not very nice looking color, but and you convert the orange to CMYK, let's say, it's not, in this case it might work because it doesn't have any cyan components. But in some other cases where maybe your orange has like 5% cyan in it, then the overprinting rules that you can use in PDF will not be sufficient to get you the same appearance after having done the color conversion. You can hack around that. We offer you a possibility to use the multiply transparency blend mode to simulate the effect. It's mathematically not the same effect, but it looks similar. But you may run into a roadblock. Nonetheless, it's being done, so I think most of our customers that use PDF Toolbox in the context of a printing plant will probably do color conversion from spot to process a lot of the time. We do get support cases, but given how many jobs are processed, the number is still relatively small. When you display subtractive color spot colors, and this is kind of not doing production printing, but anything else, including displaying on screen, but also rendering on a proof printing device or whatever. Then on the screen you can actually do quite well because you would render into a virtual printing machine that has all the inks that you need, and then you go from that virtual buffer to your screen and you can do the right thing. That's what we do in PDF Toolbox and what Acrobat does. If you want to go to a printer, depending on how much of the original data you want to maintain, if you don't want to render the whole thing into an image and then send it to a printer, you will run into the same issues as you have for doing color conversions in production printing. So, what does CXF-X4 bring to the table? I think I don't have a slide here that actually explains what it is. Do you get the idea of CXF-X4, like spectral data for spot color? Somehow? For certain people in the industry, especially coming from packaging printing, label printing, and so on, these are segments in the industry that deal with spot colors much more often than publication printing. So publication printing you can do with 4 colors. And they have found out that it's pretty difficult to predict the appearance of combinations of colors printed on top of each other. And whether you print a spot color on top of a process color or two spot colors against each other, and using spectral information about the inks, it at least looks like you can predict more reliably what the effect is than by just doing the usual math, which takes the process color spaces like CMYK for the alternate space for the spot color and the CMYK for all the other inks, and then just combine them into a mixed value. The problem is computations based on spectral data are not as advanced and widely understood as computations based on tridimensional values, which is what you do when you combine process colors, because it all goes back to LAB or something like that. And if not everybody is on the same level, implementations will be different. So if I have two companies that are experts in spectral data processing, let's say ColorLogic and GMG, pretty good companies in the field, so they know their shit, so to speak. And they combine orange and, let's say, cyan and predict what the rendering will be on a given press using these inks. The results will not be the same. Both results might be better than just using LAB and alternate spaces and so on, but they will not be the same. And if something is not the same, it's not good, at least not in the printing industry. So whatever you can get out of using CXF when predicting appearance of color will contain some secret sauce as of today, and the companies that have such technology are not ready to share the secret sauce yet. They still have to recover their R&D efforts. So I know from some people that I've been in touch with for the last 10 years, they have been hiring people and working on this for 5 years, 7 years, whatever. So there's many years invested into these computations. They have come quite far, but they need to recover 5 or 7 man years of development work, and they are not ready to make it open source. That's also the reason we cannot make an ISO standard that tells you how to do this, because at least one party would have to disclose their algorithms and then say, well, I propose this as the standard algorithm. So still people claim that because we have spectral data entry in PDF 2.0 and we can put CXF data for spot colors inside the PDF 2.0 file, and then maybe also in a PDF X6 file, which is coming next year or the year thereafter. It's not clear what you do with it. There's no definition in PDF 2.0 what to do with it. PDF X6 will say it's out of scope, so PDF X6 itself will not tell you anything about it. It doesn't block you from using it, but it also very clearly declares it's not part of the PDF X6 file exchange. So if your printer gets it wrong and you have put spectral data inside your PDF X6 file, you can't blame the printer for not doing the right thing with the spectral data, at least not on the foundation of just PDF X6. So, from my point of view, CXF X4 doesn't bring too much added value inside a PDF file. At least from my point of view, it's not ready for prime time yet. It's secret sauce time. Maybe 5 years from now, things look different. But as of today, it doesn't help. It can help for closed environments, yes? So if people work together in like kind of a closed loop environment, yes, could be very helpful, but not in an open exchange. So you don't have to throw CXF X4 away. You can do things with it. And one option, for example, is to use it outside of PDF files. For example, to generate better alternate spaces and tint transforms. Yeah, if you think about my nonlinear green, yeah, you could use your CXF info and create good alternate spaces. not just 100% values that get interpolated, but good representations of the behavior of the spot color across the continuum from 0 to 100%. Of course, programs that we use would have to be improved as well. So if InDesign and Illustrator don't make use of that information, it's not very useful. But it's easier to convince Adobe to improve the behavior of current features than to introduce new features based on spectral data. So Adobe has made it very clear they will probably not ever implement support for spectral data in Creative Cloud. It's too remote a business opportunity for them. They rather make money elsewhere. So no spectral data in InDesign or Illustrator or Photoshop. But I could envision them improving handling of alternate spaces for imported material, or for definition of spot colors in InDesign and Illustrator. You could also use CXF X4 data to generate n-channel profiles. Yeah? If you have your algorithms, if you are ColorLogic or GMG or one of these other companies that master this technology, you could use that and turn the combination of spot colors where you have spectral data and your CMYK data into a decent n-channel ICC profile. And then you have something you can carry around. I can make my secrets, from my secret source CXF algorithms, I can make an n-channel profile. And once I have the n-channel profile, I can give it to you, and the behavior would be the same because it's the old ICC architecture. Of course, I need applications that support it. And there are not many, but at least it would work. It would work based on technology that is already, in essence, 20 years old. So n-channel profiles have been specified, I don't know exactly, in 1998 or so, have been around for 20 years. Support for them has not been around as long because it was difficult for a long time to make them, but to use them is less difficult. N-channel profiles also work relatively well in the context of PDFX. We have PDFX 5N, which is a flavor of PDFX to support n-channel profiles. We will have the same, or more or less the same, for PDFX 6. One other thing you could do is also just use CXF in the background. So we see a lot of browser-based front ends for interacting with PDF content for print. So why not do some rendition of your screen preview in the browser based on the spot color you have in the PDF file, based on CXF data you have, maybe using secret source software to compute your color appearance based on the CXF data, make a nice image of your PDF page and send that to the browser. And then give the customer the right expectation of what they will get if it actually gets printed. And as I mentioned, it's absolutely okay to use CXF X4 today in a number of special scenarios, like closed-loop workflows, where a small group of people work together, like a brand owner and two printers, and they decide on a certain workflow. It can be extremely helpful. Nonetheless, broad adoption and blind exchange between people who don't have an agreement with each other will probably remain a big challenge for quite some time to come. And what's needed to get there is some specification or standard that defines how to do it. Somebody will have to give away the secret sauce, or maybe 2 or 3 parties agree on some form of what has been secret sauce, share it, discuss it, turn it into a public specification or international standard. Without that, it will be like it is today for a while. And when talking or discussing all this, it's always important to understand what we are asking for. So many cases, I hear people who are proponents of CXF or spectral data processing say, you can get the best possible result. Cool. But if it's the best possible result, it's slightly different for each of those who offer something. There's too much variation. So many would at least prefer consistent results. Maybe not perfect, but pretty good, and more or less the same between different parties. Because that also impacts predictability and operability. I want the same printed product when I send it to printing plants. If they each do their best, but it's not the same best, it will be different. If you put them on the same shelf, not nice. And of course, we may want to ask for broadest possible user agent support, not just Acrobat Pro. If you figure out how to get your settings right, maybe more. And you may still want to look for the perfect solution, but then I have to tell you, dream on. So that's where we stand. That's it. I think I was pretty fast.